All right, so here is an example of solving a, I don't want to say simple, but not horribly complex trig equation. Now with this one, I think what would trip up most people is the cosecant here as opposed to one of our original sine, cosine, or tangent trig functions. It's really not much different though, and we're going to go through the same process. So, oh, lost the lights. And I'm back. All right, so with this problem, there's a couple of routes we can go. But I would say probably actually the only one I can really think of is to go ahead and, since I only have a binomial here, I'm going to go ahead and add 2 to both sides. Okay, well that'll just leave me with cosecant squared is equal to 2. Now I don't want to know what cosecant is. I want to know what the square. Or I want to know what I don't want to know what cosecant squared is. I want to know what cosecant is. So I'm going to go ahead and take the square root of both sides. That'll leave me with cosecant is equal to plus or minus. Don't forget about that. Root 2. Now the plus or minus is just telling me that I can have, again, I'm going to have multiple answers, and in fact, it's going to tell me that I'm basically going to be in every quadrant. But the real key to this is to realize that what this really means is if cosecant equals this, then that tells me that sine is going to equal its reciprocal. Okay? Cosecant is the reciprocal of sine, therefore what sine will be equal to will be the reciprocal of this. In other words, it'll be plus or minus 1 over root 2, which I can rewrite as plus or minus root 2 over 2. Well, that gives me a lot of information because that tells me this is a 45, 45, 90 triangle. Okay. So I can go ahead and actually in this case, I know for a fact if it's root 2 over 2, there's only one type of triangle can be. My reference angle absolutely has to be pi over 4. Okay. Now, since it's plus or minus, well, that means that I'm looking for where sine is positive or negative. Well, sine is positive or negative in every single quadrant. Now, this particular problem asks us only to find the solutions between, I forgot to write this up here, between 0 and 2 pi, where 2 pi is not included. So now I look at my graph, and I'm going to have a few options. I'm going to have one option with pi over 4 here. Okay. I'm going to have another option with pi over 4 here, and hopefully you can kind of see where this is going. Another option here and here. All of them with reference angles of pi over 4. Because with all of these, I could create, if I just dropped a perpendicular down, I could create these 45, 45, 90 triangles, which will get me my root 2 over 2 for sine. Okay. And now the only goal I have is I got to figure out what these actual angles are. So if I'm writing here, I'm going to write that x is equal to, well, one of them is going to be pi over 4. And then the other one is going to be all the way around to here. Well, that's just 4 pi over 4, okay, which is equal to pi minus this section, pi over 4. Well, that's going to leave me with 3 pi over 4. Move to the next one. I'm going all the way around here. Well, that's just 4 pi over 4 plus an extra pi over 4, giving me a total of 5 pi over 4. Okay, and then the very last one, I'm going to go all the way around, and I'm going to be just pi over 4 shy of 2 pi, which I could also write as 8 pi over 4. So since I'm 1 shy of there, I'm just going to be at 7 pi over 4. Okay, and you can of course refer back to the for this one you can of course refer back to the I'm blanking here, to the unit circle, but you should be able to do it just using the reference angles and building these 4 triangles.